The next 3 videos will be on solving systems of equations, linear equations. We'll break it down into graphing first. So we'll have 2 linear equations. So for example, x plus 2y equals 4, and 4x minus 5y equals negative 20. And we're going to solve them by graphing, meaning we're looking for where they intersect. That is the solution, is where they intersect. So we'll take each line at a time, and I have some graph paper here I can write on. So looking at it this way, if you can, when the equation is written in this form, which it's called standard form, you'll learn that next year, but when you have the x term plus the y term equals a constant term, and if the coefficient of each of these terms goes evenly into this term, then you can do it using intercepts. So 1 goes into 4 and 2 goes into 4. So we cover up, you'll remember this, if we cover it up, x equals 4. So on the x-axis, you can graph a point at 4, 1, 2, 3, 4. So we know it's going to cross the x-axis at 4. That's the x-intercept. We'll do the same for y. Solving for y here, cover up your x term, solve for y, you get y equals 2. So on the y-axis, you can graph 2. So then you can connect these guys to create a line. I might actually do another line here, or another point, just to help me out. There we go. There would be our line. X plus 2y equals 4. So then let's look at the second line. Do both of these coefficients go into the constant evenly? Yes. So this is nice and easy to graph. So if we cover up the y term, we've got x equals negative 5. So over here we'll graph 1, 2, 3, 4, 5. And then if we cover up the x term, we've got y equals 4. 1, 2, 3, 4. All right, and then we will carefully, oh boy, I didn't do it very carefully, did I? This is where rulers come in handy, straight edges. Oh, a mess. All right, and then where they intersect would be your solution. It's not going to be, in this case, it's not an exact, nice and exact, but that's okay. It looks like around negative 2, 3-ish. Okay, so this is negative 2, 3-ish. All right, we'll get into precision when we do the other 2 methods, but for the graphing, I want you to use your straight edges and get as close as you can. So let's do an example where maybe it doesn't work out quite as nicely as this for graphing the x and the y intercepts. So let's say y equals 3x and 5x minus 2y equals 1. So we're going to figure out where they intersect, or what their solution is. So we'll take the first graph first. This is in the form y equals mx plus b. Well, there's no b, so what is it? 0. So we graph the 0, and then we rise 3, we run 1. So 1, 2, 3, run 1. 1, 2, 3, run 1. 1, 2, 3, run 1. So there is our line right there. There's that line. Okay, so then 5x minus 2y equals 1. 5 does not go into 1, and 2 does not go into 1 evenly. So when you run into a problem like this, let's put it into y equals mx plus b form and see if that's more helpful. So let's see, we'll isolate the y. So 2y, pardon me, I'll move this out of the way. Negative 2y equals negative 5x plus 1, right? I subtracted 5x from both sides. Divide everything by negative 2. So y equals 5 over 2x minus 1/2. All right, I still have a b of a fraction, but half is a lot easier to deal with than something funky like 5/7. So here we go. Negative 1/2 is your y-intercept. So we're down here. Negative 1/2 is my y-intercept. And 5/2 is my slope, so I rise 5, 1, 2, 3, 4, 5, run 2, 1, 2. So it looks, oh boy, this is going to be a skinny one. Again, use rulers. Okay, so these are our lines, and we're looking to see where they cross. It looks like they cross right around there, so let's see, that's like -1/2. We'll say, I'm just estimating, -1/2, -1, -1/2, -1. So that's the other way you can do that. All right, so there's the graphing. Go ahead and work on that and come back when you're ready for, we'll do, I think, substitution next. All right.